So welcome to our second webinar on reconciliation. I ran one back in December. Hopefully I've learned a bit from that and might not waffle on so much this time. We've also learned a bit more on the audio and video side, and learned that much of how well you can hear and see the presentation is a function of the bandwidth at your end. And not much we can do about it at our end. Your microphones are turned off, so you guys can talk as much as you like. I will open it up for questions at the end, and we will switch your microphones on then, and you guys are welcome to fire any questions that you like. Excuse me. So this presentation stems from a talk I did at a Mindsight Reconciliation Conference back in December on the Gold Coast. And most of the speakers there were talking on ore reconciliation or coal reconciliation. I guess I thought I just would expand on that a little bit, because to me reconciliation is not just about ore or coal. And so I actually created this presentation around other mining engineering related areas, although I will just touch on coal reconciliation a little bit. And Tom put this together for me, and previously it was called It's Not Rocket Science, and so you'll see there's a certain theme that runs through this presentation around the whole rocket science issue. Just a quick bit about me. You guys both know me a little bit already. So 23 years in the mining industry, 10 years in all of the mining engineers, drill and blast, drag lines, truck scheduling, etc., before working as senior engineers, superintendent and tech services manager. I started MB Mining back in 1999. A couple of years ago we renamed it to Echelon Mining. And then recently we've merged with Extract, who basically carry out geology, geotech, mining and corporate, and the mining side anywhere from due diligence and feasibility all the way through to putting people on site. I have 20 years in coal, 3 years in iron ore, so there will be a bit of a bias towards coal in this webinar, but a lot of it is applicable to just as applicable to metals as well. I'm a bit of a jack of all trades, master of none, so there certainly won't be any rocket science in this webinar. And I guess why am I passionate about reconciliations? In my time in the industry, I've worked at and for many mine sites that run at coal losses over 10%, and probably just as many who don't even measure them and don't even know what they run at. And I sort of always think of that as, imagine a car assembly line running at 10 to 15% rejects when they got to the end. And I guess I'm always been somewhat astounded at that. And I don't imagine that those sorts of factories and so on would stay in business for very long. And I think it's the fact that the high profits that run in the mining industry and so on, that we get away with running with high losses. So as a business owner, I've paid for myself to attend various speakers, and deciding whether to go or not, for me it always comes down to a decision as to whether I will get one thing or one takeaway from it. If I walk away with one learning or some change or improvement, then for me I've got value out of it. So my hope is that everyone gets something, at least one thing out of this webinar, to at least justify your time that you've spent listening. Now, why should you be reconciling? For me, reconciling, the reasons for reconciling can be split into two categories. The first one is about corrected or more accurate numbers. So during the period, it's likely that truck or bucket factors have been used, and to give progressive numbers throughout the period, and a reconciliation process at the end of the period is really about using more accurate things such as survey or conveyor numbers and so on, and incorporating stockpile adjustments and those sorts of things, and removing some of the inaccuracy of the period to date reporting. The second reason is to learn. It's really sort of that whole definition of insanity of doing the same thing over and over again and expecting a different result. So reconciliation is the opportunity to learn. Was there a stuff up? If so, why did it occur, and what will you do differently next time? For me, the other thing as a planner, mind planner, has always been to make future design and scheduling more accurate. It's sort of part of the feedback loop, and I guess I'm intrigued, or I ask the question of people of how do they decide what parameters to use now in future design and scheduling. And I have seen many mines where it is mandated, where a number comes down from above somewhere that you've told to use, and even in those scenarios I would still want to be calculating reconciled and historical numbers to say, well, look, that's fine, but here's what we've run at in the past or whatever, as some support. And I think the last thing is actually understanding whether your processes on site, particularly in the operations side, are capable of implementing the design or the schedule that you've come up with, or is the design or the schedule actually too detailed? And sometimes you've got to put reconciliation systems in place before you can understand exactly how accurately you can do things, and that's an interesting part in itself. So there's lots of definitions of reconciliations around. I like to keep things simple. I have a really simple definition of reconciliation, and that is that reconciliation equals opportunity. It's really about one thing. It's an opportunity to learn from your mistakes. To me, if you're not doing reconciliations, then you're missing out on that massive opportunity. And it's about closing that whole feedback loop. And for me, the ultimate aim would be to improve future design and execution at the mine site. Now, those are your employees leaving the mine site in a hurry. They're not normally dressed in a jacket and so on. It'll normally be high vis, but we have a dynamic workforce today that typically tends to have a fairly high turnover rate, and so I always like to stick with the keep it simple theory, and I think that's what should be incorporated into the whole reconciliation process. Don't overcomplicate it. It must be capable of being implemented and maintained and managed by a transient workforce, one that has sort of a fair sort of turnover, and it must also be capable of being sustained through that change of personnel. And I got a story there from when I was at Paraburdoo Iron Ore Mine many years ago, and I was a specialist mine planning engineer, and I moved into the grade control superintendent's role, and I actually was lucky enough to have about a 3-day changeover with the guy who was in it previously, and half the time that doesn't even occur these days. And somewhere in that 3 days, he spent about 5 minutes showing me the reconciliation spreadsheet that I had to fill out at the end of the month, because it really didn't rate a high priority compared with other things about the operation. And so next end of month, I really couldn't remember much of what he told me, and made up a lot of numbers in a hurry because I didn't have much time to do it, and I had to get it complete by a certain time. And that sort of happened for a couple of months until I actually found the time mid-month, one of the months, to actually sit back and look through the spreadsheet, understand what it was doing with everything, and realise that what I'd been doing for the last couple of months was a bit of a stuff up, and I hope people weren't doing too much with the numbers that I'd given them, because they were clearly wrong. And that's a bit of an example of the whole keep things simple Now I'm only going to talk on other areas, but I couldn't help myself, and I certainly sort of felt the need to have a little bit of discussion on some coal or ore reconciliation, and I guess just quickly discuss an example of one that we put in place. So I worked for a mining contractor at an operation a number of years back, and we had a coal losses target of 4%, and if we didn't achieve that 4% target, then the penalties were pretty stiff, which to me was fair enough because the loss of coal cost a lot of money, and I figured that steep penalties were pretty fair. And so how we set about doing that, a key part of the process was putting a reconciliation process in place. And the first thing we did was we had a geological model, and we created what we called a survey or a grade control model, which was every opportunity in the mining operation in pit that we had to pick up the contact zone between the coal and the waste on the either side. We took that opportunity, and so we built what we called a survey model from contact zones picked up within the pit, and we considered that to be more accurate than the geological model, which was based on drill hole spacings of something like 100 metres. And so we used that grade control model for the future reconciliation, but we compared the two, and the difference between the geological model and the grade control model was a reflection of the accuracy of the geological model. And in terms of the person accountable for that, whilst it might have been someone managing the exploration side, I mean, the closest person that we could find on site to hold accountable for that was the tech services manager. So the tech services manager was accountable for the difference between those two. What we did then was we took the grade control model and we said that's what we have in pit, that's what the production manager should be held accountable against. And so we looked at the difference between what the grade control model said was there and what the actuals were that we actually got. And the difference between those two was a mining recovery, which we held the production manager accountable for. Now then we took the actuals from the pit and we multiplied those by yields and moisture adjustments, etc., and worked out what we should have got out the other end of the prep plant. And then we compared that with the actuals that we did get out the other end of the prep plant, and the difference between those two was effectively how well the prep plant was washing the coal. And so that we held the processing manager accountable for. And so we ran at under 4% for 3 years or so that I was there, and a lot of that was actually about the culture, and that started with the accountability and setting clear accountabilities. So there's various types of reconciliations, and for me one of the key categories of reconciliation is a comparison of design versus actual. And so for me, design is always carried out in a perfect world, and this is our perfect world. This is design. Design is the best case scenario given everything that you know right now. So theoretically, it's the best way that you can do it because you've designed it on paper in a computer or whatever. And so I think it's fundamental that we compare actuals against design so that we know what was different and what changed so that we didn't achieve design or effectively what sort of should be perfection. So reconciliation is a comparison between two sets of figures, which might be plan and actual, or it might be past period and current period, and so on. But there's numerous other areas besides just ore reconciliation. So there's drill and blast, there's waste movement, mine scheduling, mine design, and mining equipment performance. And so we'll talk about some of those in this reconciliation webinar. So what we'll do is we'll just go through some examples of reconciliations in those different mining operational areas. but there'll be no detailed tables or calcs. That sort of is go to sleep type stuff, and so we're just going to talk about things from a general conceptual level point of view. So let's start with drill and blast first. And again, like I say, it's very much about design versus actual. So from a design point of view, where were the drill holes to be located? What were the design drill depths? What was the design powder factor for the shot? And what were the actual hole charge designs and the design tie-up? And then what actually occurred for each of those, and why was it different to the design? And what were the critical issues? So, for example, in blasting, often the critical issues might be around front burdens or those sorts of things. And how did you go on the critical issues? Now, all of that comes at some sort of an effort from a labour point of view, although I can't help but think with today's technology, surely it could be made more efficient via iPhone apps or those sorts of things. But the question is it worth it? And so if we do a value example, and what I've done is I've said what's the cost of one bad shot, and so if let's say it's a shot in a coal mine, typical large shot for a dragline or something like that might be around about 500,000 cubes, and you were aiming to get a cast of about 15%, and because of some issues with toe, or whatever it might be, shot didn't go so well. You got a cast of about 8% instead. So you've got a cast reduction against design of about 7%. Now, also, let's say that the bottom 10 meters of the shot has been dug at a reduced productivity of about 60% or so. So that means on average for the whole shot, your productivity reduction was 12%. And if you're digging at dirt at about $3 a BCM or something like that, then basically the cost of that bad shot in terms of the extra dirt that you had to dig because you didn't cast it, and then the reduced productivity across all of that dirt is about $290,000. And so that's more than the cost of a full-time person just on drill and blast reconciliation. So someone's only got to save one bad shot of that size, a couple of bad shots of a smaller size, or whatever it is to pay for themselves. Other drill and blast areas that you should be thinking about reconciling. Certainly, scheduling of drill and blast is fairly critical in the mining process. It's pretty often a sort of a pinch item in the scheduling. Can't start until the activity above it has been completed. Has a tight deadline as to when it's got to be fired by, because there's some excavation equipment coming into that path and so on. So schedule versus actual is actually a pretty important reconciliation. And so what was the mining schedule as it related to the drill and blast processes, and what actually occurred, and why was it different? And for me, that's very much about getting to the heart of the issues. More often than not, something like drill prep is the bottleneck in the process, but who actually schedules, monitors, or reports performance on drill prep, for example? So it is about understanding what are the problems in the process, and if that needs scheduling and monitoring and so on, then so be it. Redrills, that's effectively rehandle, and so there should be some sort of reconciliation of actual drill meters versus design drill meters. At many mine sites, I have seen issues between drilled volume calculations, blasted volume calculations, and excavated volume calculations. Those three volumetric calculations are often worked out on a different basis that result at different volumes. Over time, when you start recording inventories or things like that, then they often can get out, and I've seen some big differences in numbers between those and some unexpected write-offs, etc., which is an ugly process. The blast quality, I would argue that there should be some sort of a blast quality score, some measure of the blast outcome. Realistically, there's four key things in blasting. Firstly, safety, things like fly rock and misfires and those sorts of things. The diggability of the shot, whether you wanted it to move or not, and then also how well you protected the coal or the ore. So there should be some sort of a blast score process, and then you can actually compare design blast score versus an actual blast score. And it's not to say that the design blast score is going to be 10 every time, because sometimes that you know when you go to design a shot that the windrow's in the wrong place, or there's water somewhere or something, and you can't get the holes where you want them to be drilled and so on. So a true design score for a shot is actually a reflection of some issues in the first place. So if we move to truck shovel now, same thing, design versus actual. So what were the design parameters for the shot? Bench width, bench height, ramp locations, any rehandle, those sorts of things. What were the design productivities for that area, and where was the material designed to be hauled to, and therefore how many trucks were required. And then again, what actually occurred for each of the above, and why was it different from design, and what were the critical issues? Were they things like truck efficiency or whatever, and did you get those right? Again, as I say, that comes at some effort, so is that worth it? So if we look at a case here where we assume that we're moving about 30 million cubic metres per annum, which is, say, with 4 diggers and 20 trucks. Now, 20 trucks at 5,000 hours a year is about 100,000 truck hours, sorry, and at $300 an hour, so that's a total truck cost of about 30 million or so. Now, truck and shovel reconciliations can result in improvements in lots of areas, but I figured I would just use trucking for this example, because I believe it's an area that's typically not as well designed and understood as it could be. If you've got a fleet with 5 trucks, then those trucks are normally more than about 50% of your cost. And it always intrigues me that all the focus is on digger productivity. How often do you hear people talk about truck productivities, for example? So let's say that by focus on the whole trucking process, looking at haul route inefficiencies and removal of those, or better management of truck numbers through having long dump and short dump options as daily truck numbers available vary, and those sorts of things, focusing on delays and all those sorts of things, that you could improve the truck productivity by 5%. What that means is that your new annual truck hours are now 95,000 instead of 100,000, and at $300 an hour, that's a saving about $1.5 million in operating. And then potentially also that you need 5,000 less truck hours in a year now, so theoretically 1 less truck is required, and so there's potentially a capex saving as well. And so if a person costs you roughly 300,000 a year, then that sort of works out that for each labour hour they spend on the whole truck shovel reconciliation process, they've got to save about 2 truck hours for themselves to break even. So, other truck and shovel reconciliations that you should be considering: dump swell factors. Most sites tend to use a constant factor. Very often it's been there for over a day and no one even knows where it necessarily came from. That's all fine until you have a tight or a critical dump, and when it all goes wrong, and then things can get pretty ugly. Truck factors are used for volume movement calculations during the period until such time as something more accurate becomes available. And so poor truck factors sometimes can lead to nasty surprises at end of month. And trying to explain those write-downs sometimes can be a difficult process. And short-term, long-term versus medium-term versus short-term designs. So did they vary from each other, and why? Which is somewhat of a reflection on the design process. Next area for discussion is draglines. So design versus actual. What was the design method for that area? Design parameters, things such as the key width, bench heights, dump location, that sort of stuff. Design rehandle and design productivities. And then what actually occurred for each of the above, and why was it different? And what were the critical issues? Was it things such as spoil placement and so on? And how did you go with those critical issues? And again, that might all come at some sort of expense. So is it worth it? And so what we might do is just do a bit of a reverse engineering example here, where we say you've got 3 draglines on site and it's 300,000 for a person to reconcile for those 3 draglines. So that's 100,000 per dragline per year that you're spending. So what's the actual performance improvement required to get a return on that money? So if the dragline is costing you about 7.9 million a year in operating and maintenance, then you basically need a production improvement of about 1.3% from the focus on that dragline to get your 100,000 back. And which means that if you're running at about 2100 BCMs an hour, you need to get it up to about 2127 instead. Or if you're running at 6,500 dig hours, you need to get to 6,583. Or if you're running at 45% rehandle on the dragline, you need to get that down to 43% rehandle. The reality is that via focus on the dragline, you may well achieve improvements in all 3 of those areas. So in actual fact, it might be a smaller fraction of the 3 of those to pay for that person. So other dragline area reconciliations you should be thinking about. Swell factors, similar to the truck. Often it's a number that's been a constant number used for a long time. It is critical in the dragline horizon and the method design process, and there's nothing like the spoil not fitting to cause rehandle to absolutely go through the roof. So I would suggest that dump swell factors in the dragline are a fairly sort of critical number. Bucket factors, again, that's all about trying to reduce any nasty surprises at the end of a month or end of a strip. Most mine sites aim for some sort of a percentage of RSL, which is 100% or more. And I would argue that if you are targeting more than 100% RSL, there should be some sort of reconciliation process of actual loads against the targets. And draglines are infamous for their poor performance in terms of coal recovery. So why not relate roof and floor losses, or in particular roof and edge losses, to each dragline? And then we come to the holy grail of reconciliations. For me, what's a real biggie, and that's actually the reconciliation of plan versus actual for mine scheduling. In my 20 plus years in the mine industry, I've seen very few mines that actually have a culture of following the plan, and I haven't seen many either who actually measure actual against plan. And if you want to carry out that process, for me, a key part of that change starts with implementing the comparison of actual versus plan. Given that mine schedules typically have a shelf life of about 5 minutes or so, then the simple fact of the matter is that there will be variations between actual and the schedule. And for me, why don't we start with labelling those variations as non-conformances? That's actually what they are. And so let's change the mindset around, well, we didn't follow plan. Why didn't we follow plan? And it was a non-conformance. And then there's two main things really. Was the non-conformance a sequence based? So for some reason, someone somewhere changed the planned sequence of some equipment, or was it purely a quantity based thing? So you scheduled a certain quantity for a piece of equipment. That quantity wasn't there for that piece of equipment, and so therefore it finished earlier or later or whatever. So they're probably two of the sort of the main areas of non-conformance. And then what were the key non-conformances in any schedule? There's some activities that have flexibility and some don't. There are some activities that are bigger drivers in the process of the achieving of a plan, which somewhat equates to, in the project management terminology, the critical path. What was the critical path? And so therefore, what were the key non-conformances, and why did they occur? Now, I'm not going to work out a rough cost of following plan. That's probably, I think, venturing a bit more into the mine planning area. I would certainly say it's difficult and subjective, but to me it's a bit of a no-brainer. Why do the planning if you're not going to follow it? Now, the thing about all of those examples and so on that I've just discussed, is that none of this is rocket science. None of it's complex. And I would argue that given reducing commodity prices and so on, there's actually never better time than right now to be putting effort into reconciliation. For me, it does very much fit under the banner of working smarter, not harder. And I guess I've always liked the saying that you can't improve without measuring. So I would argue that now's the time to be spending more money, not less, but in the right areas. And the thing that's always intrigued me is that mining companies will always have a required return on investment for capital, for equipment, etc. that they might buy. There'll be target thresholds of it must have a return on capital of at least 25% or whatever. Why don't they have return on investment thresholds for their people as well? I mean, if you could go and spend $200,000 on an employee and they improve the profit by $400,000, that's a no-brainer. But it always intrigues me that the value of people is never assessed in terms of whether they should be put on or they should be put off, and so on. I think that if you take a lot of examples and look at it, the right person carrying out the right work is going to have returns on investments of 500% or more. And so I think they're a quantum leap from a lot of actual capital investments. So thanks everyone for listening. I hope it was worth it. I hope that you did get at least one thing from my talk. So please feel free to contact me to speak about anything at any time. My email's there and so on. And we're now just going to open it up for questions. Good culture. And so Joseph's asked for my experience in developing good culture in planning and reconciliation. So I think good culture is driven very much by knowing firstly knowing what it is that you're supposed to be doing, and then secondly measuring how well you're doing against that. So from a reconciliation point of view, what is important to the mine site? What should you be reconciling? And I must admit, I find it intriguing. Trucks is always an interesting one for me. There are plenty of mine sites that have something like 50 to 100 trucks running around, and there's a complete lack of planning and reconciliation of trucks, and yet there's a lot of money being spent on trucks. So I think it's a matter of identifying what's important, planning those accordingly, and then measuring back against the plan, and holding people accountable. I think clear accountabilities is important. And certainly that comes back to KPIs. I've seen many mine sites with the wrong KPIs that drive the wrong behaviour, and I think it's about having the right KPIs. Mostly tech services are facilitators of planning for operations and so on, but I think it's about tech services working with the mine operations team to ensure that the plan is implemented. And so I sort of think that tech services KPI should reflect actually some actual things about implementation of the plan. So I hope that answered your question. Danny, yes, I agree, and it's sometimes driven, as you say, by getting someone from outside to come in, and then you get into that whole people on site have been saying something forever and a day, and no one ever listens to them. But as soon as someone external comes in, everyone takes it as gospel or whatever. But I think that some of that starts with, it does actually come back to the whole, to me it actually comes back to a culture and what you sort of have in place and so on. So for example, back when I was at the coal mine and we were running at less than 4% losses, we did actually have a driver of large penalties which both operations and tech services understood. But we took the role of what tech services took the role of what assistance can we give to operations to ensure that we run at 4%. And so, for example, I sat down and drew up a table that we printed on a laminated version and gave to each of the supervisors, which said to them, for example, a grader cost $160 an hour or something like that, and we were penalised $25 a tonne or something that we didn't get or something. So if in 1 hour that grader could recover 6 tonnes of coal, then it paid for itself in terms of you putting that piece of equipment on that operation. So we did that for graders and dozers and people and all sorts of things. So we gave the operations people the tools to make the decisions for themselves and so on. And so sometimes that whole cultural and sensitivity thing is got to be about, well, we're all working together, we're all here to do the same thing, so how is it that we in tech services can help you guys, and what is it that we can provide you, etc.